Okay, okay. Hello guys. So today we're gonna explore this way package data. So the problem with data is the provider, the user want to improve the marketing page. So in this data, 80% of the consumer, only 18% of the consumer purchase the package, and the marketing is quite high because it's contacted at random, right? Okay, so in this problem, we would like to reduce the marketing costs and create a model that predict if a marketing pitch will be effective or not, like that. Okay, here is my code. So, oh, sorry, I kinda messed up there. Okay, um, so to create to define this problem, it can be as straightforward as a model to predict if a customer based on their characteristic will they take the product or not. But I want to make it more relevant to marketing, so I create it as a Bayesian probability, right? So it's not only will the consumer take the product, but it's will the consumer take the product after a marketing pitch. So it's the basic environment. I changed the style because for that exploration, 38 is my favorite. Okay, here is the data. So we have customer ID and product taken is the product is the product taken or not. One means the product is taken by the consumer. Zero is no. And type of contact. Here is the variable that I think related to marketing costs, right? If the company actually invited someone to take the product, it incur the marketing cost, right? And self inquiry, so it's not. So I in my data in my analysis I filtered the consumer. We only use the company invited one. Okay, here is another company's the consumer's characteristic. And oh yeah, also duration of pitch is also interesting actually, but I don't use it because actually it's also relevant to marketing cost because a longer duration pitch, especially if the consumer is a company invited one, the telephone cost is paid by us, right? Yeah. Okay. Okay, this is another customer characteristics, and for the first time I checked if the customer ID have any duplicate because we have very small data set. I think it's only about the raw is only about 4,000. So if there is any duplicate rows, it will be very frustrating. It is my filter. I only filter the component method one because yeah, the Bayesian probability. I want to check from this characteristic only from the customer that's um, invited by the company that get a marketing pitch. Okay, and yeah, we also drop some looking for leakage and also customer ID because it's unique. And yeah, of course the target variable, type of contact because it's only communicated, pitch satisfaction, and product pitch and duration of pitch because we assume that the consumer isn't already pitch. So the model can be used like, okay, if I pitch this one, will he take the product? Something around that frame. Okay, so this code here is to calculate the null value, and we have 57 null value on age, duration of pitch, and but the one thing that really nice is the null values is actually um, mainly not categorical ya, so it's easy to impute. Okay, so after the filter we only have 1400 data. It's really small, and this is, yeah, basically it's what I am saying, because if we call it an effective marketing page, the type of context will be campaign invited and the customer take the product, and otherwise it's not effective. Okay, because of the target variables actually categorical, I try to make it into non-categorical. Oh no, in this one, because it's a visualization, I make it into categorical. Yeah, yeah. So if the protein is one, basically is yes, and else is no. Okay, here's the visualization. So the component method one is smaller than self-inquiry actually, so it's kind of good. And yeah, this is the ratio of the people that taken the product after the marketing pitch. So in the company that one, only 21% actually take the product. Duration of pitch. Okay, so the people actually have not that 75% of the people don't have duration pitch more than 25 minutes, so it's actually less than 25 minutes. Either it's they take the product or no, or self-inquiry or command invited. But yeah, when people take the product, the range, the income interquarterly is actually larger, so I think we can make a weak assumption, but it's really weak assumption though. And this is uh, the pitch follow-up. So the higher the follow-up, the customer will be more likely to take the product. Okay, satisfaction. Okay, here we select our feature and we use train test split, and obviously we stratify why, because yeah, we don't want to for the y to go larger in either of the set, the try or testing set. Okay, and here I separate between categorical columns and numerical columns. And then we try to find its cardinality. Basically, we calculate the number of ununique, right? So, fortunately, our data don't have much cardinality, but our rows is really small, right? So, it's kind of frustrating to pick between this categorical columns. You know the rules 1 in 50. Yeah, so basically we can only have maximum of 20 features, and 3 plus 3 plus 4 plus 5 plus the numerical columns, it's uh, it's kind of frustrating, right? The small dataset is really frustrating. So we choose with chi-square. We try to find if the variable actually uh, important or not. So fortunately the gender is have p-value more than the significant statistic. So we choose this three variable, and then yeah, and we try to find multicollinearity. So the rule of thumb here is the multicollinearity if the variable correlates more than 70%, I think. So we don't find a multicollinearity only, yeah, slightly, like number of visiting person and children. Yeah, it's obvious that it's correlated. But unfortunately, these two variables don't have really high uh, F score, and because we already choose three categorical feature with really kinda high cardinality, it's actually low, but yeah, with our data rows, with our small data, it's high. So we choose the top three. I think it can really, it's the feature that explain data really nicely with this F score. And then, yeah, uh, we actually just impute the column, right? Uh, because the categorical column don't have any don't have any null value. We impute only the numerical column. We use median inputter, and then we to to make the categorical column a numerical value, we use get dummies. Okay, here is our one hot encoded uh, categorical columns, and in our final train and final X test, we can get both. Okay, and this is the function to compile. Okay, so first here we want to check the current performance. Like this all of this data is the from the pitch consumer, right? So we predicate as, yeah, the consumer will take the product if they pitch. It's the most effective marketing, right? But 20 2022 people, 222 222 people actually is a false positive. So it's much efficiency, and here is our objective. We want the true positive rate is higher than false positive, because false positive here means ineffective marketing. And we want the true positive is higher than the false negative, because yeah, it just kind of wasted. It's an opportunity wasted, right? So after we create the features, and we try to find how much the ratio between our features and our column, our rows. So it's actually 25. Yeah, it's still kind of low. I want it like one in 100, but yeah, it's enough, because the bare minimum for me is 1 in 50. Okay, for the baseline, I try to use logit segregation, and the outlook is this, so it's kinda acceptable because it's more than 20%. Yeah, 70%. Then, but when we try to find the conversion matrix, the false positive rate is higher than the true positive. So yeah, it's still ineffective marketing. We wasted so much time on these 52 people here. So we want to try the three best algorithm, and the overall is higher than logit segregation, and the conversion matrix is actually better too, because yeah, we only have 10 false positive and 20 false negative. So the true positive is higher than both. Okay, so it means that we actually reduce the ineffective marketing, and we don't really waste too much, but we still want to improve it. So we try to use XGBoost, and here is yeah, it's just manual tuning from me, and from the tuning we got this conversion matrix, so it's better than the random forest, right? So the true positive increased to 45, true negative, the false negative decrease, so we get much people, right? And here is the classification report. So our precision for the for to predict unpotential people is really nice. We have the precision of 93% and a recall of 95%, but to predict the potential consumer is kinda still low, so I still try to improve it. So in this column, because we have pretty unbalanced data, only 20% of the people actually buy the product, so it's 1/4 ratio. So in this in in this next session, like uh, I tried to see if there is an outlier, but I think there is not really, not any significant outlier, etc., etc. And oh yeah, this one problem. I don't understand why in every of my model here the PR curve is after the 80% recall is just dive down. So damn, the precision really gets hit really hard in this one. Yeah, okay. And yeah, the outlier is not that much, only 2 on each. And yeah, it's not that much, I think. But yeah, I try to train the XGBoost using another train set, so it's actually a resampled one. So I oversample, so the Y, so the people that take the product and people that don't take the product have the same ratio. I use the random oversample, and here's our model after we try using another oversample dataset. So it's kinda better, right? We have true positive label predicted is 48, and we have less false positive and less false negative. And the classification report is actually increased for the precision when they are predicting the true positive. And yeah, but the problem is here. It's still here. The PR growth really dives down when the recall more than 80. So I don't understand why. And any feedback on this will be very much appreciated, guys. Okay. And yeah, I try to maximize the recall using threshold tuning. So basically our model default threshold is 50%, right? And I try to lower it kinda, and yeah, it got a better true positive result. And yeah, the the model can predict very much better with the 40% threshold of probability. Okay, so the precision actually increased to 70% and the recall increased to 80%. And the negative prediction is actually increased a little bit too. And yeah, basically that's the model. And how can we actually use? The recall is actually 94%, so we can slash 94% of the ineffective marketing costs, right? So we don't we don't pitch these negative predicted people, and yeah, they can predict up to 80% of the available potential customer, and with 70%, 79% of precision, it means that for every 5% that's predicted by the model that they will take the product, there is still a risk that one of them actually is not that potential. And here is just a compilation of my model. So threshold 4, and the model is XGB2, the sampled one. And and yeah, that's just basically the model. And oh yeah, so we actually want to see from the last year data. how many of the customer that self-inquire, so there is no effort from us to pitch them, that actually potential, predicted potential by our model, you know. So the first filter is self-inquiry, and the second filter is the consumer don't take the product. It's waste, but yeah, we want to know how much, right? Okay, we already filtered the data, and then we name it the dev test, and this is the function to process the data, and then this is the prediction. So okay, to for the easier interpretation, I change 1 to potential and 0 to not potential. And here is it, guys. So based on the filtered dataset from the customer that self-inquiry, so they are not pitched by us, there's actually 530% that self-inquiry and they didn't take the product after the end of their self-inquiry. It's a shame that there is this much of a person. There is potential if we just pitch them. So yeah, I think this model can increase your revenue too. So you can better predict consumers that will be will take the product that's potential if you just pitch them. Okay, I think that's all for my video. Goodbye to the next session. Peace. Almatos and Vikri. I'm get out from here.